Andrej Karpathy, who you just mentioned, a leading expert in AI who works at OpenAI, just released a public version of a talk that he's given called The Busy Person's Intro to LLMs, Large Language Models. Now, on the surface, this is a 1+ hour video. It's very useful, highly accessible introduction to how large language models work. It has a bunch of very practical examples. I'd highly recommend anyone with a deeper interest in this take a look at it. But as part of this video, Karpathy also speculates on the future of LLMs. And in doing so, he highlights a couple of really important points that I think give us some clues as to where all this may be headed. So first, he encourages us to think of LLMs not as chatbots. It's actually more correct to think of them as the kernel process of an emerging operating system. So LLMs as an OS. And second, LLMs as operating systems in just a few years, by his estimation, may increasingly be able to use different media and actual tools, digital tools, to solve problems just like humans do. So he says we could see relatively soon LLMs that have capabilities like having more knowledge than any single human about a given subject, the ability to browse the internet, use existing software infrastructure to complete tasks, in certain narrow domains, actually self-improve at how it gets its results, and obviously understanding and generating text, images, video, and audio. He also does call out the idea, Paul, that you highlighted in the previous topic, the ability to think deeply on hard problems for a longer time than just a snap judgment. And last but not least, he predicts we may have LLMs that could communicate with other LLMs. So there's a little more going on in this video than just a 101 class on LLM. So Paul, can you maybe connect those dots a little further for us?
So first, I think it's good to revisit Karpathy's background. So he was actually a founding member of OpenAI. So he was there from January 2016 to June 2017. We talked about Andres in February 21st this year, episode 35. So if you want some more background on him, and a paper he worked on called World of Bits was the key thing that we focused on. And I actually wrote a blog post about it at that time as well that we'll link to. But in essence, he then went on after OpenAI to work at Tesla. He led the AI team there, and he developed the computer vision team that was critical to full self-driving. So he played a key role there. But then when he announced he was going back to OpenAI in February, actually February 8th of this year, that was what caught my attention and led to me writing a blog post, going back and re-listening to an episode he had done with Lex Friedman, a podcast interview he had done. I was trying to figure out, why was he going back to OpenAI? What was going on? And so he actually alluded to it. I'll read a quick excerpt from the transcript of his interview with Lex Friedman, because Lex asked him, like, why are you going back to OpenAI? What is going on? Or like, really, what do you think the future is? This was before he actually announced he was going back. He said, do you think there's a future for that kind of system interacting with the internet to help learning? So they were talking specifically about like AI agents. We've talked a lot about how the future is going to be these agents that can take actions, not just produce outputs. So Karpathy said, yes, I think that's probably the final frontier for a lot of these models. So as you mentioned, when I was at OpenAI, I was working on this project, World of Bits. And basically it was the idea of giving neural networks access to a keyboard and a mouse. And the idea is that basically you perceive the input of the screen pixels, and the state of the computer is visualized for human consumption and images of the web browser and stuff like that. And then you give the network the ability to press keyboards and use the mouse, and we're trying to get to it. For example, complete bookings and interact with user interfaces. So again, the reason I'm giving this context is you have to understand Karpathy went back to OpenAI in February of this year to work on what I'm explaining right now, followed by Noam Brown in July, followed by what has happened over the last 2 weeks. It's all connected, trust me. So Karpathy then goes on to say, now to your question as to what I learned from that, it's interesting because the World of Bits was basically too early. So again, 2016, 17, it was too early to give these AI agents the ability to take action. This is around 2015 or so, and the zeitgeist at the time was very different in AI than today. He said, it is time to revisit that, and OpenAI is interested in this. Companies like Adept, which we've talked about before on the show, are interested in this and so on. And the idea is coming back because the interface is very powerful, but now you're not training agents from scratch. You are taking the GPT as an initialization, meaning the ability now for the AI to understand and generate language. So GPT is pre-trained on all this text. And so now the agent understands what a booking is. It understands what a submit is. It understands quite a bit more. And so it already has those representations. These are very powerful and make all the training significantly more efficient. So Karpathy is critical to a lot of the last like 7 years of AI. He's been a key player. And so he went back to OpenAI to work on these interactive agents, but in the process, obviously goes very deep on language models. So he doesn't publish often on YouTube. And so when he does, you pay attention. And so I found this video extremely intriguing on a number of levels. So first was I think it gives a great overview of how a large language model works. I would say it's like it's not a beginner level introduction, I wouldn't say. Like I feel like you need some basic comprehension of large language models for this introduction to make sense,
Mhm.
but it's definitely kind of like a 201 level. It is not highly technical. Like I really think everybody should go listen to it, maybe listen to it a couple times, depending on your current familiarity with large language models. But I really do think it gets this great overview of how they work. But what I want to focus on is like the last 20, 25 minutes of the video where he went into what comes next. Now, I found this intriguing because one, I think he's right, obviously. I mean, he knows more than I do. Two, it confirms everything I've been hearing from the other research labs. Three, the timing is really intriguing. Like the fact that he's presenting this as, hey, I'm not saying this as OpenAI doing this, but this is what the research labs are doing because they're all connected. They've all worked with each other the last 10 years. He knows what the other labs are doing, just like Jan LeCun knows what the other labs are doing.
Mm.
So I think it's fair to say the things we're about to go through are things that not just OpenAI is working on, but OpenAI is definitely working on. So, one, large language model scaling laws. So we hear this term scaling laws all the time. What does it actually mean? What it means in their case, and this is one of the things I kind of learned from this, is it is all about the accuracy of the model at predicting the next word. So today, large language models are basically predictive engines around what the next word is it should write. And so what he's saying is so far, the more parameters we give these things, the more training data we give them, and then the time we spend training them, they pretty we can pretty much predict how accurately they're going to generate the next word. And that his opinion and their data says that shows no signs of topping out. So, in essence, training bigger models for longer and you get more powerful and accurate results. We're going to talk about a number of these foundation models in the rapid fire today. So, what he said, and again, I find the use of the wording interesting. We can expect a lot more general capability across all areas of knowledge as these models get bigger. So that was one. Two, connecting to and integrating tools makes the models more capable. So think about what they've been doing with ChatGPT. You had code interpreter, you have Bing search added, it has calculator now, it has image generation and recognition, it will have video generation and recognition, it will have audio generation and recognition. So what OpenAI has been doing thus far is connecting tools to the model. They're not baked into the model per se. Now, I think GPT-5 will be different. And the reason I think that is because I just read an interview with Sundar Pichai of Google, and he said that Gemini, their approach is different in that these tools are built into the foundation model itself. So they're not going out and building an image generation tool and then connecting it. That's what BART is today. But the next iteration, these models will all be built right in. These tools will be built right into the foundation model. So truly multimodal, which is number three, which we know, again, they're building in these capabilities of images, videos, audio, text, code, all of that is getting built right into the models. Number four, this goes back to what we talked about earlier. And I think this is really interesting concept. So he talked about a book called Thinking Fast and Slow by, I forget the guy's name, Daniel something. And in that book, which I bought, I haven't read it yet, they talk about system one thinking is instinctive. It is what the large language models are right now. So a system one model, you give it an input and it immediately gives you an output. just takes its training data and spits out the answer. System two thinking, you have to work things out in your head. You think through possible outcomes. You think through the implications of those outcomes. Maybe in the Q learning model, you think through the potential score or value of the future state once you take the action. So he said that is where we are going, is we're going to build models that have this reasoning capability. And so the more time you take to generate the output, the more accurate the prediction becomes. So right now you can sort of see parts of this where if you tell ChatGPT, like, take your time or think it through step by step, it tends to improve the accuracy. Now, interesting again, how it's all connected. Meta on November 20th just released a research paper called System 2 Attention, and then in parentheses, is something you might need too, which I actually laughed at. So you'll appreciate that, Mike. So we go back to the origin of all this, 2017, the Transformer paper. The title was Attention is All You Need. So Meta System 2 Attention is something you might need too, is kind of funny. So in there, they basically talk about this premise that the more time you give these models, the better they get at reasoning. Number 5, my takeaways and what he highlighted in the future was self-improvement. And so he talked a lot about AlphaGo. So again, if you haven't watched the AlphaGo documentary that tells the story of DeepMind beating the world champion at Go, watch it. You will understand this even more. So he talks about how, traditionally these models learn through imitating human experts at players. But what AlphaGo did, what the DeepMind team did, was they enabled self-improvement by enabling it to play against itself. And the reward function was, did you win or not? And so the way that AlphaGo got way better, got superhuman at the game of Go, was it played itself millions of times and it learned what to do. So he asked the question, Karpathy is like, what is the equivalent for large language models? So right now, these models use imitation of human labeling and training data. So he explains, like, you build the model and then humans go through and, provide labeling and training of the data. And so it just basically imitates us. So the question becomes, and I think this is where the real potential breakthrough in QStar is happening, is how do we move to self-improvement of these models so where we don't have to rely on human labeling and training of the model once it's been created? So the question that they grapple with is, what is the reward function? So in a game like AlphaGo, you win or you lose. That's the reward. You get more points if you win than if you lose. But in a language model where it just creates an output, how do you reward that? How do you know if it was good or bad? Right now, there's a thumbs up or a thumbs down. Like maybe that's part of their early effort. But he said it's not easy to evaluate reward function in an LLM. And so I made the note to myself, like, is this the breakthrough? Like, did they find a way to provide a reward system? Because right now they can only do it in narrow domains. And so he said it's an open question in the field, but my thesis at the moment is maybe it's not as open as we think of a question. That if they could find a way to drive self-improvement, that would rapidly scale the capabilities of an AI toward AGI. The number 6 was customization. We want to be able to customize and have them become experts at specific tasks, thus the GPT model. So they enabled this early on through GPTs where you can go in and create your own version of ChatGPT. It lets you add knowledge. And then a real key, it uses retrieval augmented generation, or RAG, as probably heard about lately if you follow the space, to create outputs. What that lets you have happen is, rather than relying on a general ChatGPT model based on GPT-4, you give it documentation, like your internal documents from your company, and say, look up the answer here. So it then goes and retrieves information from the source data you've provided. And he also gets into a little bit about fine-tuning models. And then the last thing deals with what you talked about, Mike, of this operating system idea. He shared a really, I thought, a slide that's, I think, potentially really important. Like, we'll look back 2 years from now and be like, oh, he just laid out the whole roadmap. And I think that's what he did. So I think at the end, he actually said, here's what we're working on. Here's what everyone is working on. This is what we know is already happening. So I'll just highlight those bullet points and then turn it back over to you, Mike. So the first is the LLM in a few years, is how he wrote it. It has more knowledge than any single human about all subject, which you touched on, Mike. It can browse the internet or reference local files through RAG, retrieval augmented generation. It can use the existing software infrastructure, calculator, Python, mouse, keyboard. Mouse, keyboard goes back to the world of bits. It can see and generate images and video. We're starting to see that happening. It can hear and speak and generate music. We're starting to see that happening. It can think for a long time using a system two. That's the one we just touched on. That's coming. It can self improve in narrow domains that offer a reward function. That's what we just touched on. It can be customized and fine tuned for specific tasks. Many versions exist in app stores. And then it can communicate with other large language models. So I don't know. I mean, I think when you process everything he talks about, it actually starts to become pretty clear where the breakthroughs could have happened. And again, I think it could be any of them, but I think it's probably a safe bet it has something to do with reasoning capabilities and the reason Noam Brown joined OpenAI. It has to do with giving it more time to process things. And I would make a big bet that self improvement has a real key aspect of it. They have found some way to self improve because once you do that, it becomes harder to keep these things from progressing at a rate that we're not prepared for in society. So I know that was a lot. Mike, you watched it too. Is there anything that I didn't touch on that jumped out to you or just any other thoughts you had about it?
No, I just think it's worth reemphasizing that what we're talking about is literally the speculation from a very informed person building this technology that we are going to very quickly have large language models, or call them multimodal models, whatever term you want to use, that can know more about subjects than any single human and can do all these things. And that to me sounds like something severe enough that they almost torpedoed and destroyed the entire company over fears about it. So I think the severity of the response, whether it was right or wrong or indifferent, is something to keep in mind as you are evaluating this, because I don't think you torpedo one of the top companies on the planet over hypothetical concerns personally.
Yeah, I think it's reasonable to assume that the outline of those last few bullet points I said, like LLM in a few years, that isn't the blueprint for GPT-5.
Hmm.
Like that's what they're building. It's what everybody's building. It's what Gemini probably looks like. Um, So yeah, I just again, like you said, the key for us is we just go to the source. Like we're not looking at some, overnight AI expert or influencer online and like trying to draw some conclusions. This is years of tracking like the key players in the industry, trying to connect why does Gnome go this, 3 months after Andrej? Why is super alignment announced the day after Gnome joined? Like, why
Hmm.
has all this happened? And I think when you start going to those, the actual sources of the information, when they're willing to put it out there in interviews or online courses or whatever it is, you have to really add, again, like a language model, you have to add heavier weights to the information coming from the actual sources. And I think in this case, there's probably a lot to what he's laying out beyond just his ideas. I think this is very real about the blueprint being followed within these research labs.
Yeah, and I would just as a final note add that if you go back over the past year, especially, but even further back, your predictions on a lot of this stuff have been quite spot on. Obviously, we don't get everything right, but your strategy of going straight to the source and reading between the lines has predicted some of these things functionally months in advance.
Yeah, and like that's I think Gnome is a good example of that, and Andrej too. Like there's no coincidences in this space. Like I've been studying this space long enough to know that, there's usually reasons why all this stuff appears to be connected because it actually is connected.